Empirical formula. This is a series of videos where I talk about percent composition, empirical formula, and molecular formula. In this video, we are going to be doing practice problems, calculating the empirical formula using data. So the first two problems will be calculating an empirical formula using the mass of each element in a compound. And in the third problem, we will be calculating an empirical formula using percent composition. This is an example problem about empirical formulas. A lab analysis of a 12.080 gram sample showed that the sample contained 2.901 grams of carbon and 9.179 grams of fluorine. Determine the empirical formula. So this compound has two elements, carbon and fluorine. And we want to figure out how many carbon atoms and how many fluorine atoms there are in this molecule in their smallest whole number ratios. So we want to come up with an empirical formula where X and Y are in the correct ratio but smallest whole numbers. Now, the data that we got from lab, we have masses of carbon and fluorine. These are in units of grams. Carbon atoms and fluorine atoms have different masses. So we are going to need to convert these masses into numbers of atoms. A mole is a certain quantity of atoms. 1 mole would be 6.022 times 10 to the 23rd power quantity of atoms. So I can use masses from the periodic table for carbon and fluorine to convert these values of grams into moles. So let's start with carbon. We have 2.901 grams of carbon. And I want to convert this to moles. So I'm going to look at a periodic table and find the mass of carbon on a periodic table. You would find 12.011 grams per mole. We need to divide by that number, this mass from the periodic table. You want units of grams to cancel out in order to convert into units of moles. So 2.901 grams of carbon divided by the mass of carbon on the periodic table, 12.011 grams per mole, you get 0.2415 moles of carbon. Now we need to do a similar calculation for fluorine. We have 9.179 grams of fluorine. 9.179 grams of fluorine. We are going to need to divide by the mass of fluorine from the periodic table. This would be 18.998 grams per mole. And you would calculate that you have 0.4832 moles of fluorine. 0.4832 moles of fluorine. Now, these two numbers, these are quantities of atoms. These are in the same ratio as the values in our empirical formula, but we want them to be in the smallest whole number ratio. So let me rewrite this equation using these values that we just calculated. Imagine that our number of carbon atoms was 0.2415, 0.2415, and our number of fluorine atoms is 0.4832, 0.4832. The definition of empirical formula is these same quantities, but in their smallest whole number ratio. What I generally do to convert these into a smallest whole number ratio is I take whichever number is the lowest and I divide them both by that lowest number. I'm going to divide both of these by 0.2415. 0.2415 divided by 0.2415. When you do this, you generally end up with either whole numbers or decimals that are easier to figure out, such as 0.5 or 0.3 repeating. Remember that empirical formulas are small whole numbers. So when you have your number of carbons, 0.2415 divided by 0.2415, that is 1. fluorine, 0.4832 divided by 0.2415. That is very, very close to 2. And we are looking for small whole numbers, so I'm going to go ahead and round this. Now, there's only one more thing we need to do here is empirical and molecular formulas don't specify 1. 1 is always implied. So our empirical formula would be CF2. This is our answer. This is our empirical formula. This is an example problem where we are determining an empirical formula from the mass of each element in a compound. Lab analysis showed that a sample was composed of 5.31 grams of chlorine and 8.40 grams of oxygen. Determine the empirical formula. So whenever you have masses of each element in a compound, you are going to want to convert those into numbers of atoms. So remember that the empirical formula, this is a formula that tells us lowest whole number of atoms of each element in a compound. Chlorine and oxygen atoms have different masses, so these are not directly comparable in terms of number of atoms. So I'm going to need to go to a periodic table and find the molar mass of chlorine and of oxygen. So chlorine, according to the periodic table, has a mass of 35.453 grams per mole. And oxygen, according to the periodic table, has a mass of 15.999 grams per mole. I'm going to need to use these masses to first convert these grams into moles. Mole is a quantity of atoms. So let's take our 5.31 grams of chlorine. 5.31 grams of chlorine. I want to convert this into moles of chlorine. And I know that there are 35.453 grams in 1 mole of chlorine. I am going to need to divide by this molar mass. 35.453 grams per mole. Whenever you are using an atomic mass or a molar mass to convert between grams or moles, you decide if you divide or multiply it based on what makes your units cancel out. 5.31 grams, we are going to need to divide that by grams. So we are putting grams in our denominator, moles in our numerator. So 5.31 grams of chlorine divided by 35.453 grams per mole equals 0.150 moles of chlorine. Now we need to do that same calculation but for oxygen, starting with our 8.40 grams of oxygen. 8.40 grams of oxygen. I'm going to need to divide by my molar mass of oxygen from a periodic table, divided by 15.999 grams per mole. And I get 0.525 moles of oxygen. 0.525 moles of oxygen. I'm going to write those quantities that we just calculated in the format of an empirical formula. So I'm writing Cl subscript 0.150, O for oxygen subscript 0.525. This is not our empirical formula. However, these two numbers are in the proper ratio. We need to multiply or divide both of these numbers by the same quantity in order to turn them into whatever their lowest whole number ratio is. So when I'm looking at numbers like 0.150 and 0.525, it's not easy to see exactly what I might need to multiply or divide both of them by to convert them into their lowest whole number ratio. So what I always do to start is take whichever number is the lowest and divide everything by that number. So I'm dividing both of these numbers by 0.150. So for chlorine, 0.150 divided by 0.150 is 1. We don't bother to write the 1 in either an empirical or molecular formula. For oxygen, 0.525 divided by 0.150, this is 3.5. We have a different formula. This is still not a proper empirical formula, but we still have chlorine and oxygen in the right ratio. They're just not lowest whole numbers. But when I am comparing 1 to 3.5, it's a lot easier to figure out what I might need to do to both of these numbers to convert them into their lowest possible whole numbers. I'm going to go ahead and write this subscript 1 right now. What I'm going to need to do is multiply both of these numbers by 2. I am basing that on the fact that I have a 0.5 and I want to turn it into small whole number. So multiplying both of these by 2, I would get Cl2O7. 1 times 2 is 2 chlorines. 3.5 times 2 is 7 oxygens. And this Cl2O7, this is my empirical formula. In this problem, we'll be calculating an empirical formula using percent composition data. A sample contains 24.01% carbon and 75.99% fluorine by mass. Determine the empirical formula. The easiest way to do a problem like this is to assume that these percentages are instead grams and that your total sample size was 100 grams. Assume these values are in grams and you have a total sample mass of 100 grams. So if you had 24.01 grams of carbon and your total sample had a mass of 100 grams, you would have 24.01% carbon by mass. Likewise for fluorine, the math would work out there as well. When you make this assumption, you can do this problem the exact same way that you did the previous example problems. I am going to take 24.01 grams of carbon and convert it into moles. 24.01 grams of carbon. I'm going to need to divide this by the molar mass of carbon from a periodic table. 12.011 grams per mole equals 1.999 moles of carbon. Likewise for fluorine, assume that your 75.99 is grams. 75.99 grams of fluorine divided by molar mass of fluorine from a periodic table, 18.998 grams per mole. And you get 4.000 moles of fluorine. So let's write those values that we just calculated in the format of an empirical formula. So for carbon, we calculated 1.999 moles, and for fluorine, we calculated 4.000 moles. I want to put these numbers in their smallest whole number ratio. I am going to divide both of them by this lowest number, 1.999. So for carbon, we end up with just 1 carbon. For fluorine, we end up with 2, or something very, very close to 2. Remember, we're always looking for small whole numbers. So when you see something that clearly rounds to 2, it is okay to go ahead and round that in this case. So our empirical formula is CF2. We have a ratio of 1 carbon to 2 fluorine atoms in our molecule. So the overall goal for this series of videos was to determine the exact number of atoms of each element in a molecule. That's what we're going to be doing in our next video. We are going to be converting empirical formulas into molecular formulas. In order to do that, we are going to need one more piece of lab data, and that's going to be the molar mass of each compound. Thanks for watching. If you feel that I've earned it, I ask that you like this video and subscribe to my channel.